So example number 5, while riding in a Ferris wheel, a person dropped a candy bar from a height of 20 meters. Now in this case, the Ferris wheel is moving, so the person inside is moving, and of course, what is the time of flight and final speed of the candy bar if the Ferris wheel was moving up, and then if the Ferris wheel was moving down. So two situations. Let's look at them both. So here's the Ferris wheel, and initially, in the first case, the Ferris wheel is moving up, and the person dropped the candy bar. So even though when you usually say drop, that means the initial velocity is 0. In this case, because the Ferris wheel is moving, the initial velocity isn't 0, but it's positive 8.5. And of course, the acceleration of gravity is going to be 9.81. And the displacement of the object from the point of release to when it hits the ground is going to be negative 20 meters. And of course, they want to know the time of flight and the final velocity. Well, the time of flight is a very difficult one. Let's take a look at that. D is equal to VIT plus 1/2 AT squared. Now the problem with solving for time here is that time is in this part of the equation and time is also here. In math, you have something called the quadratic formula that would help you to solve for this, but a little more complicated than it needs to be. What I suggest we do is solve for the final speed first and then use that final speed to find the time of flight. So let's retrack and say VF squared is equal to VI squared plus 2AD. We have all the information we need. The initial velocity is 8.50 meters per second squared plus 2 times 9.81 negative times negative 20 meters. And what we get with that is 72.25 meters squared per second squared plus 392.4 and that gives us a total of 464.65. 464.65, and that of course is meters squared per second squared. So VF is going to be the square root of that, and it's 21.55 meters per second. And of course we know that it has to be down. When it hits the ground, it's moving down. So there's your final speed when it hits the ground. And now that we know the final speed, we can calculate the time of flight, because since A is equal to VF minus VI over T, then T is equal to VF minus VI over A. And that's equal to negative 21.55 minus 8.5 divided by negative 9.81. And so we get a time of flight divide by 9.81, and we get 3.063. All right, 3.063 seconds. That's the time of flight if the Ferris wheel was moving up. Now, if the Ferris wheel was moving down, it's interesting that VF squared equals VI squared plus 2AD. Even if the Ferris wheel is moving down, it turns out that this would be just negative 8.5 squared plus 2AD. What we end up with is exactly the same number, 464.65. So that's meters squared per second squared. And we end up with the final velocity of negative 21.55. So whether it's going up when it leaves or down when it leaves, it still hits the ground with the same speed. But of course, if it's moving down, the time of flight is going to be a lot less, because of course, taking this solution here, T is equal to VF, which is of course negative 21.55, but the initial velocity was not positive 8.5, but negative 8.5. And we divide that by negative 9.81. We get a much smaller number. It's going to be 21.55 minus 8.5 minus negative 8.5, which is the same as adding. And so we only get a difference in velocity of 13.0 because it doesn't have as much time to pick up speed. Divide that by 9.81, and you get negative, or you get 1.33 seconds. All right, so when you throw it up, it takes longer. 1.3308 seconds should be your answer. So here's the time of flight going up. If it's going up, this is A. Going down, this is for B. And notice that the final velocity or final speed is negative or 21.6 down in both cases. All right, excellent little question.